In this session, we'll discuss MCQs related to topic rate and order of the reactions. The first 25 already recorded, so I will start with 26. In question 26, a reaction has a rate equation. So rate equation is given for rate is equals to K times the rate constant times the concentration of X, concentration of Y square, concentration of Z. The concentration of each reactant is shown in the table. If the rate of a reaction under these conditions has a value of 0.24, then what is the numerical value of a K? The concentrations are also given for each. So we need the value for K. The rate equation is given that rate is equals to K times, like rate equals to K times the concentration of X, concentration of Y square, and concentration of Z. We'll just only substitute as the value for rate is given, so which is 0.24 equals to K, the concentration of X. So what is the concentration of X? That is 0.040 or 0.04. The concentration of Y, which is 0.2, and then square will be there, and concentration of Z, that is 0.1. So we need the value for K, the numerical value for K. So all these factors will be divided. So it will be equals to 0.24 divided by the product of 0.04 and 0.2 square times 0.1. When we multiply all of them, we'll get the value for K. So what's the answer for this? $1,250. So that's option D. So D is the right answer. The next part of the same question, 26 part B. What is the unit of a K? Look how we can work out the unit of a K from this equation. The unit of the rate is already given here, which is moles. Like this is a unit of the rate, moles per decimeter cube, second inverse, or mole decimeter raised to power -3 second raised to power -1. Means we can write as moles per decimeter cube second. That is the unit of this rate equals to K. The unit of concentration for X, that is moles per decimeter cube. Then the unit of concentration of Y, that is also moles per decimeter cube, but this one is squared, so this will be square. And the unit of concentration for Z is moles per decimeter cube. So when we solve, this moles per decimeter cube will cancel with this moles per decimeter. So here we are left with 1 over second, and this one is K. This is square multiplied with mole and dm cube. So this will become mole square and dm cube 6. So mole square dm cube 6 times this will be moles divided by dm cube. When we further simplify, so it is 1 over second is equals to K. Moles square multiplied by moles, so it will become mole cube. dm cube 6 multiplied by dm cube 6. So sorry, this was 6 here, not 3. So dm cube 6 times dm cube 3, that will become 9. When we cross multiply, so this will be dm cube raised to power 9. Second is there and mole raised to power 3. That is equals to K. Or K is equals to dm cube 9 mole raised to power -3, second raised to power -1. So this will be the unit for K. So when we check the options, like mole -3, second -1, and dm cube 9, so it matches with option A. So A is the right answer. Is it clear, this one? The unit of K. Okay. Moving on to the next question. In question 27, in aqueous solution, iodine reacted with propanol in the presence of a catalyst of hydrochloric acid. Iodine propanol reaction is there. Which of the following method could be suitable to investigate the rate of reaction? There are different ways to investigate the rate of reaction, like we can measure the volume of a gas given off. We can measure the change in the mass for the content in the flask. We can observe the color change during a reaction. We can like first we will take a sample out, then quench and then titrate. That can also be done. And conduction also, like if the ions are there, number of the ions are changing, so we can find how many, like what is the change in number of the ions. We can also use that method for measuring the rate of reaction. So which is suitable? Measure the increase in pH with a pH meter. So here, as you can see in the present in the presence of catalyst hydrochloric acid. So hydrochloric acid is a catalyst. Catalyst is a substance which alter the rate of reaction, but chemically it does not change. So means as hydrochloric acid is an acid and it is acting like a catalyst, so it won't change. Like during a reaction, it might change, but the overall change will be negligible. No change, because catalyst is a substance which alter the rate of reaction without chemically being changed. So if the acid won't change, the pH of a solution does not change. That's why method A is not suitable for measuring the rate. For method B, measuring a change in rotation of a polarized light with a polarimeter, that depends on if we have optical isomers. If we have an optical isomer, like example C double bonded with O and CH3 are there, and CH3. For to be an optical isomer, like or a chiral carbon, there must be 4 different groups attached to the carbon. But here what happened, you can see like identical groups are attached here, so this cannot be an optical isomer. Same thing when a product is formed, CH2I. So this is different group, CH3 is different, but 2 of the bond is with oxygen. So this molecule, because to be a optical isomer, the carbon must have 4 different types of surrounding, 4 different neighbors should be there, or 4 different types of bonds must be formed. But in this case, the reactant and the product does not affect the polarized light. That's why this second method is not suitable. So polarimeter or polarization of a light is useful if we have a chiral carbon. A carbon is forming 4 different bonds. Quench with ice cold water and then titrate with acid. Why? We can quench, but we cannot titrate with acid. Why we cannot titrate with acid? Because here there is no reagent which is reacting with acid in the reactant or a product side. Because when iodine is there, we should quench, like slow down the rate of reaction, and quenching can be done by changing a temperature or adding any reagent which stop the reaction or slow down the reaction, then followed by titration. So if iodine is involved, then iodine can react with thiosulfate. So we prefer iodine thiosulfate titration. So option D, quenching with sodium hydrogen carbonate. Because what will happen, the sodium hydrogen carbonate will react with the acid. So it will remove the catalyst. As it removes the catalyst, the reaction will slow down or it will stop. And then we will titrate with the sodium thiosulfate because iodine is there. if it is in the reactant or in a product side iodine, we can use the sodium thiosulfate titration and find the rate of that chemical reaction. That's why D is the right answer. Is this clear? So if iodine is involved, then thiosulfate titration, iodine like first quench and then titrate with thiosulfate. If alkali was there or acid is there in the reagent, then we can use, or any substance which is reacting with acid or an alkali, then we can quench. And quenching can be done by two ways, either adding a certain reagent or by changing the temperature or a condition for the reaction. In question 28, hydrogen peroxide decompose in a first order reaction. So if it's a first order reaction, the first order reaction have the constant half-life. Half-life of the first order reaction is constant. Like example, if you have 100 gram, it will turn into 50 gram in certain time, like say 50 seconds. So same 50 gram will turn into 25 in the same time interval. So half-life for the reaction is 60 seconds. In this experiment, the initial concentration of a hydrogen peroxide was 0.1. The concentration of hydrogen peroxide at 120 seconds. So initially, how much hydrogen peroxide was there? 0.1. That was in the beginning of experiment. Then after half-life, because half-life is 60 seconds. So after the half-life or after 60 seconds, how much it will be? It will be half, so we'll have 0.05. Then after another half-life, after another 60 seconds, or total after 120 seconds, it will be 0.025. So the concentration of a hydrogen peroxide after 120 seconds, which means after two half-life, will be 0.025. So for a first order reaction, the half-life is constant. And if we have a graph for concentration and time, graph is there. If there's a concentration time graph, so what we simply do, like example, 100 is there, half of 100 is 50. So same way we can work out. For a first order reaction, half-life is constant. If it's a second order reaction, initial half-lives are shorter, but then it increases. But it is not constant. Is it clear? Then to determine the activation energy for a reaction, a graph is plotted between ln k and 1 over t. And Arrhenius constant is A. The gradient of the graph, how to compare? We compare with the equation of straight line, y is equals to mx plus c. So on y-axis, if we have ln k, on x-axis, if we have 1 over t. So what will be the gradient? What we are left with? We are left with the gradient is equals to activation energy divided by the general gas constant, negative of. So gradient is, because gradient is what is left. So what is left? We are left with minus E over R. So minus E over R is representing the gradient of this graph. So for 29, D is the right answer. And for these type of questions in exam, like the structured question, usually they will give you the values for K and T. You have to make another column to get value of ln K and 1 over T. Then plot a graph between ln K and 1 over T. find the gradient of the graph, and from the gradient we need activation energy. So how to get activation energy? The activation energy is the gradient times the general gas constant, which will give us the negative of activation energy, or minus m into r will give us the activation energy. So this is also important question, like finding the activation energy of the reaction by plotting a graph between L and K and 1 over T. In question 30, a bromoalkane was hydrolyzed by an aqueous alkaline solution. The reaction was first order with respect to bromine and zero order with respect to hydroxide. Look, this is related to topic SN1 and SN2. Like, if we have a primary, if we are talking about the hydrolysis of primary halogen alkane, so for primary halogen alkane, the rate equation is rate is equals to K times the concentration of halogen alkane and the concentration of hydroxide. Like, it is first order with respect to halogen alkane and first order with respect to hydroxide, because the rate of a reaction depends on presence of both halogen alkane, and it will undergo SN2 reaction. Means the rate of a reaction depends on both halogen alkane and hydroxide, because there is a space available in a primary halogen alkane. There is a space available to attack on the to attack on the carbon which is bonded with halogen. So bond breaking and bond forming can take place at the same time in SN1, SN2. But in SN1, this happen in tertiary halogen alkane. And the rate of the reaction is equals to K times the concentration of halogen alkane. It does not depend on the presence of OH, because in a tertiary halogen alkane, as carbon is surrounded by more carbon groups, alkyl groups usually, and these like alkyl groups, they are actually electron releasing group. As a result, uh, they will make a carbon cation more like stable, and the OH cannot attack. So when carbon is surrounded by more alkyl group, OH cannot attack. So the reaction depends on the presence of halogen alkane only. But in SN2, what happens? A carbon is surrounded by only one carbon chain or one alkyl group. So OH can attack from any side and it will undergo a reaction. So in the question, the reaction, they mentioned the reaction was found to be first order with respect to bromoalkane or halogen alkane, and zero order with respect to hydroxide. Like, hydroxide does not affect the rate of reaction, but halogen alkane affect the rate of reaction. So if halogen alkane is affecting rate of reaction and hydroxide does not affect the rate of reaction, so means they're talking about the tertiary halogen alkane. So which bromoalkane is this? So you just have to find the tertiary halogen alkane. So which one of them is a tertiary halogen alkane? How we can work out? So if option A is the right answer, option A, carbon is having 3. So this is not tertiary halogen alkane. So that is A is not right. When we check option B, CH3 is there, CH2, like the second one, and Br. So this is not a tertiary halogen alkane, because to be a tertiary halogen alkane, the carbon which is bonded with halogen alkane surrounded by 3 carbons. So the B is not correct. When we check option C, so this is again not correct, because the carbon which is bonded with halogen alkane surrounded by only one carbon chain. But when you check D, The carbon is bonded with bromine and then it is having 3 carbon chains around it. So means this is a tertiary halogen alkane. And if we write the rate equation for this, the rate equation will be equals to K times the concentration of this halogen alkane. And it does not depend on the OH. So that's why D is the right answer. Is this clear? That's how we distinguish by using the initial rate method and SN1. And the rate equation, we can identify whether it's a primary halogen alkane or a tertiary halogen. Four sketches are there as shown below. Which of the graph of rate equation, rate of a reaction on vertical axis against the concentration of a reactant for a zero order reaction? So what should be the shape of the graph for a zero order reaction? For a zero order reaction, the change in a concentration will not affect the rate at all. Like rate is independent of the concentration of the reactant. So if you have concentration of the reactant, if you have the concentration of the reactant and we are having a rate, so if a concentration rate changes, the rate does not change. So it will be a horizontal line. So in that case, A will be the right answer because A is showing that changing the concentration does not affect the rate. Rate remains constant. Which of the graph of rate of a reaction on vertical axis against the square of concentration for the second order? Look, they're saying square of the concentration. So if we sketch a graph for rate and concentration for the second order reaction, if it was rate and concentration only, because if concentration double, rate will be 4 times. Concentration 3 times, rate will be 9 times. So the graph will be like this. But they mention if we sketch a graph between rate and concentration square. So if you have a graph between rate and concentration square, so if a concentration is double, concentration square will be 4 times, rate will be 4 times. If concentration is triple, rate concentration square will be 9 times, rate will be 9 times. So concentration square and rate increase with the same factor. That's why it will be a straight line for a second order reaction. Both graphs, like this is also for second order, this is also for second order. But how they're different? One was between the rate and concentration, and the second one is between the rate and concentration square. So B will be the right answer for this one. Which of the graph for concentration on vertical against the time for first order reaction? So concentration always decreases with time. If we have a first order reaction, it will have a constant half-life. So concentration and time for a first, if it was a zero order reaction, then this will be the shape of the graph for zero order. If it is a first order, the concentration time graph for the first order, it's having a constant half-life. And if we have concentration time graph for the second order, in the beginning, the change in concentration will be much faster. like drastically it will change and then it slow down. So the half-life increases. That's for second order. The concentration time graph. This is for first order and this was 0. So they asked for first order. That's why D is the right answer. And which one is a which could be a graph between ln rate and against 1 over r. So this graph is always like if a graph is there between ln r and 1 over t. Plus constant. So we have the formula y is equals to mx plus c. So on y-axis, if we have ln r, on x-axis, if we have 1 over t, what will the gradient? The gradient will be equals to minus E over r. Activation energy is constant, r is constant. So means it must be a straight line. And it will have a negative gradient. Straight line and negative gradient. So this cannot be because it's a horizontal line, means the gradient is 0. So either B can be an answer, C can be an answer. D cannot be because it's not a straight line. B can be answer C, but why not B? Because B is having a positive gradient. When we compare with the equation, the gradient is minus E over R. So this is having a negative gradient because when you take the first point on x-axis, that will be x1. This will be y1. When you take the second point, so this will be x2 and this will be y2. So y1 is above y2. It means the gradient will be negative. Here what happened when we take the first point, x1 is there and y1. And when we take the second point, x2 is there and y2. So y2 is above y1. It means when we take out the gradient, it will be a positive gradient. But we want a negative gradient and a constant gradient because like it's a straight line, so it must be a constant gradient. Is it clear? In question 32, four sketch graphs are shown below. 4 of them are there. Which could be a graph for a concentration and time against 0 order. So concentration and time. So for a 0 order, it must be like this. So B will be the right answer for concentration time graph. Then which could be the graph for rate of reaction on vertical axis against the concentration for first order. For first order, when a concentration is double, when a concentration is like first order concentration double, rate is also double, concentration 3 times, rate is also 3 times. So they are directly proportional for a first order. Concentration and rate are directly proportional. If you double the concentration, rate will be double, so D will be the right answer. Which could be the graph for rate of reaction on vertical against the square of concentration for a second order. So if for a second order rate and concentration, like this is a graph between rate and concentration for second order. If you double the concentration, rate is 4 times, triple the concentration, rate is 9. But here they did not ask, they asked which is a graph between rate and concentration square for a second order. So for a second order, because what happened if concentration is double, concentration square is 4 times, rate is also 4 times. So this is a second order graph for a second order between concentration square and rate. So again, D will be the right answer. If the question was which one is a graph between rate and concentration for a second order, then A will be the answer. But the question is which is a graph between rate and concentration square. So it must be a straight line for a second order. which could be the graph for concentration of a reactant against the time which is catalyzed by the product. Means in the beginning, the reaction is slower, but the rate of a reaction increases, but as a product increase, like product is acting like a catalyst, because there are some reactions which are known as auto-catalyzed reaction. In auto-catalyzed reaction, when a product is formed, some reagents which are formed in the product can also act as a catalyst, so the rate of a reaction increase. So in the beginning, the reaction will be slower, but because the product increase, so the rate of the reaction will also increase. So we want to a graph between concentration of the reactant. So concentration of the reactant in the beginning, because concentration of the reactant decreases. So if we have a normal sketch is there for a zero order, this one is there for zero order. So if you have concentration time graph for a first order, so it will be like this. But they mention that as the product is formed, the product is acting as a catalyst. So in the beginning, the reaction will be slower, but when the products start to form, the reaction becomes faster. And the concentration must be decreased. So either B or C can be an answer, but why not B? Because in B, the reaction rate of a reaction remain constant, because the concentration time graph, the slope represent the rate of a reaction. So rate is constant. But here what happened? As in the beginning, the concentration was slowly changing, but as the product is formed, the change in concentration is drastic. So this shows that this reaction is catalyzed by the product. That's why C is the right answer. Like rate is not constant in the beginning, the rate is slower, but then it increases as the slope is much steeper. Is this clear? Moving on to question 33. So a bromate ion is reacting with a bromide ion in the presence of an acid. Rate of a reaction can be determined by measuring a change in color intensity or change in conductivity. Which changes will occur? Change in color intensity. What will happen in terms of the color intensity? Because like these are ions are there and a bromine molecule is a colored. So change in a color intensity, the intensity of the color of this solution will increase. So the color intensity. Change in conductivity, it depends on the ions. In the beginning, we have more ions like 5, 11 and total 12. But in the product, we have molecules. So as the ions turn into molecule, it means the conduction will decrease. So the color intensity increases because of formation of a bromine, and ions are usually not colored, compounds or molecules are colored. So that's why the color intensity is increasing, but conduction is decreasing because the number of the ions are decreasing. So C will be the right answer. Then a substance A decompose in a first order, a half-life is 48 hours. Like after every 48 hours, it will become half. In an experiment, initial amount of A is 1. The amount in moles of A remain after 144. So after 144, how many half-lives are there? Like it's about 3 half-lives. Like we have 1 mole after 48 hours, 48 seconds, not hours, it will be 0.5. After another 48 seconds, it will be 0.25. After another 48 seconds, it will be 0.125. And the total duration is, this is 144 seconds. So it will change to 0.125. So D will be the right answer. Question 35. the rate of a reaction is shown. The concentration of a nitrogen dioxide is double and the concentration of carbon monoxide is half. Look, because this reaction does not depend on the other reagent, the rate equation is the concentration of nitrogen dioxide was double and the concentration of carbon monoxide is half, while the temperature remained constant. The rate constant K will, like they're not talking about rate, they're asking about rate constant K. So this is a rate constant, its value does not changes, its value only changes with if there's a change in temperature, because at different temperature will have different concentration, and the value, if it's an endothermic reaction, K will have a higher value at high temperature. If it's an exothermic reaction, if you increase temperature, K value will decrease. So the value of the K will not change. It's a constant for the equation. So constant for the equation at a specific temperature remain same. So it does not change. Which is a possible mechanism. As you can see, the rate equation only involves the concentration of NO2. So it means the rate determining step, the slowest step should have NO2. So which one is the slowest step? Like if I write the rate equation for this one, it will be rate is equals to K times the concentration of N2 and O2. So this is not correct. If I write the rate equation for this one, so rate will be equals to concentration of NO2 square and concentration of CO square. This is not correct. If I write the rate according to this one, because we always use the slowest step to write a rate equation. So it is CO square and oxygen will be there. But when we write according to this one, the slowest one, so rate is equals to NO2, like K times the concentration of NO2 square. So this is consistent with the above equation that rate is equals to K times the concentration of NO2 square. That's why D will be the right answer. Then the decomposition of a concentrated solution of hydrogen peroxide is slow at room temperature. What does this indicate about the value of activation energy and the rate constant of this decomposition? So because if a reaction is slower, the activation energy will be higher. If a reaction is faster, the activation energy is lower, like the reactant can easily reach an activation energy. And what about the rate constant? Because the reaction is slower, so the value of the rate constant should be low. If a reaction is faster, the value of the rate constant will be high. Because you can see that rate is equals to K times the concentration of the reactant. So if the value of the rate is slower, like rate constant is slower, so rate will also be slower. If a value of a rate constant is higher, value of the rate constant is higher, so rate of a reaction will be faster. So one should be like activation energy for always remember for the slow reactions which are slower, it means they have a high activation energy and a smaller value of a rate constant. So B will be the right answer for this one. Is it clear? This one? These are the MCQs related to rate of the reaction. About 36 MCQs are there.